Okay, so now we're moving into a unit on fluids. Fluids are anything that can flow, such as a liquid or a gas. So water can flow, gas can flow, air can flow. Anything that can flow is a fluid. We're going to talk about two main topics today. The first is density. And density is calculated using rho equals m over v. So this thing that looks like a P over here, that's the Greek letter rho, pronounced row, like you row a boat, and it's rho equals m over v. Rho is density, or kilograms per meters cubed, so those will be the typical units for density in physics, kilograms per meters cubed. M is mass, kilograms, and v is volume. Density is basically how much stuff there is in something per a unit of volume. So volume, meters cubed. How much stuff there is in something, kilograms. So it's how much stuff per volume. That's what density is. In fluids, we generally don't talk about the mass of a fluid because you might just mean a little bit of the fluid, like what's the mass of a cup of water, but we couldn't just say what's the mass of water because we could have any amount of water. Instead, we talk about its density, or density times volume. And density times volume gives you out mass. But anyway, instead of saying mass when we're talking about fluids, we'll usually say rho times volume, or rho times v. The density of water, it's a very common thing on Earth, so just useful to know, is 1,000 kilograms per meter cubed. Another way that I like to remember this, 1 kilogram per liter. So every liter of water, whenever you have a liter bottle of Coke, that's 1 kilogram. 1 kilogram per liter. Or 1,000 kilograms per meters cubed in standard units. Anything that has a lower density than water will float. Anything that has a greater density than water will sink. And take a look at the cartoon over here. Embedded in styrofoam shoes, Carl is sent to sleep with the humans. So styrofoam has a lower density than water and would therefore float. However, if you throw a rock in here, stone generally has a higher density than water and would sink. So anything with greater density than water sinks, anything with less density floats. You'll be working a lot with tables of densities whenever you solve problems using density. So physicists and chemists have worked for years to try to figure out the densities of a whole bunch of different things. And I'll show you how we can use this and the equation I gave you a little bit ago. Aluminum has the density 2.70 times 10 to the third kilograms per meters cubed. Make a note of that somewhere. We're going to use it on the next slide. So the density of aluminum, 2.70 times 10 to the third kilograms per meters cubed. Okay, because I know we're going to use that number, I'm going to go ahead and write that down real fast. So rho aluminum is 2.70 times 10 to the third kilograms per meters cubed. Okay? And here's our example problem. An aluminum cube has a mass of 12 kilograms. What is the length of each side? Now, this problem might at first seem nonsensical. You're like, how is mass related to the length of the sides? Well, it's related by the formula rho equals mass per volume. I know the mass, I know the density, I can find the volume. And if I have a cube, the volume of a cube is just the length of one side cubed. So length times width times height. But if it's a cube, all sides are the same length. So it's just L cubed. So once I've found the volume, I can then take the cube root and get the length of one side. So let's try this. Okay, so I need to know the volume of the cube, and I'm using the equation rho, where'd my pen go? Rho equals mass over volume. So to get volume, I would multiply volume on both sides, and I get rho v equals m. And now I'm just looking for v, so I can divide by rho. Volume equals mass over rho. Okay, now let's sub in what we know. Volume equals 12 kilograms over 2.70 times 10 to the third kilograms per meters cubed. Okay, and now if I divide that out, 12 over 2.7 times 10 to the third, I get that the volume equals 0.0044 meters cubed, since that's what I'd be left over in the units. The kilograms would cancel and the meters would move to the top, since it's in the bottom of a fraction in the denominator. And now I want the cube root of that to find the length of one side, so the cube root. And when I take the cube root of that, which I can show you tomorrow how to do on a calculator if you don't know how, I get volume, not volume. So we said that volume is length cubed. So the cube root of length cubed gives me length equals 0.16 meters. So each side is 0.16 meters long of that cube with mass 12 kilograms. Now, seemingly unrelated things, kilograms and the length of a side, but you can see how this could be useful. I might have a cube of something and need to know what it is, so I could find its mass, find its volume, and then look back at the table I showed you and say, oh, that cube is made of blah, 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 because that's its density. So maybe I got out, if we did this backwards, the cube has a density of 2.7 times 10 to the third kilograms per meters cubed. Oh, that cube must be aluminum. So you can actually identify substances using what we just did. All right, that's it for part 1, density.